Hello everyone, welcome back to the Java tutorial series. In this video, we will learn about one of the most important concepts in Java, that is object-oriented programming. It is commonly known as OOP. So we will understand what OOPS is, why it is used, and we will see real-world examples and the core principles of object-oriented programming. And also we will have a look on benefits of using object-oriented programming. So by the end of this video, you will have a solid understanding of the foundation of Java programming. So let's get started. So what is object-oriented programming? Object-oriented programming is a way of writing programs by creating objects. Okay. So object-oriented programming, okay, is a programming paradigm that organizes software around objects rather than functions or procedure. So far we have seen the methods. Okay, now we are moving into objects. So object-oriented programming focuses on real-world entities. What do we mean by real-world entities? So every object has what? Data. Okay. So every object will have data, also called as attributes or properties. Okay. Properties. So every object will have data. We call it as attribute or properties. And behavior. What do we mean by behavior? Behavior means methods. Okay. So for example, a car. Okay, imagine a car. It has properties, right? Properties like what? Color, brand, speed. So these are the properties of car. So car has properties. Now, do car has behaviors? Yes, car has behaviors like start the car, stop the car, accelerate the car, brake the car. So these are the functionality of the car. Okay, you can say like functionality. Start, stop, accelerate, or we can say brake. So these are what functionality of a car. Functionality of a car, and we call it as behavior. And properties like color, brand, speed, design. So these are like properties this car is having. So this approach makes program easier to design and maintain. What approach? Object. Okay. Object will have the data and behavior. Data I mean properties, and behavior I mean functionalities. Okay. So let's see some example. We'll have better clarity. So we will try to understand by real world example. Okay, so let's understand object oriented programming using a car. Okay, so imagine a car. The car has several properties. Okay, it will have brand, it will have color, it will have speed, and it will also perform some actions, right? Start, stop, accelerator, brake. So these are the actions this car is performing. We call it as behavior or functionality. So similarly in Java, we create a car object. Okay, we create a car object that stores the properties properties and behaviors. You can say functionality, you can say method, anything is fine. But you should understand the object. In this example, the car object will have properties, will have behavior or functionality. So this makes programming very similar to the real world. Okay. So let's understand the class and the object. Okay. So one of the most important concepts in object-oriented programming is the difference between the class and the object. Okay. Class is what? Class is simply a blueprint. Class defines what an object should have. Okay. It defines what object should have. An object is the actual implementation of the blueprint. Okay. So you can say blueprint, template, design. For example, the car is a class, okay? And individual cars. So here you can see one example. Car is a class. That means the blueprint or template or design of car, on the basis of this design, template or blueprint, the objects will be prepared, objects will be created. Okay. So think like naturally. In order to create an object, we should have some blueprint, we should have some design, we should have some template, right? So those blueprint, template, design, we call it as class. Okay, so class will define how this object will be created, what properties, what behaviors the object will be having. So those things, design, template, blueprint, will be residing inside class. So in this example, car is a class. Okay. Now, individual cars we have BMW, Audi, Tesla. Okay. These are what? These are objects. You can create 1,000 objects from a single class. Okay. Think of it class like a mold. Okay. Mold, I hope you know. Mold means some infrastructure. Okay. Some hollow structure. Okay. In which we are pouring something liquid and it is taking the shape of this structure. So this structure is called class, and the final output we are getting, okay, output in the solid form, and class was like hollow. So the final product we are getting is object. Okay. So think like class is a blueprint. It will have definition of how the object will be created, what properties, what behaviors will the object will have. Okay, those definitions will be present inside class. Class is like mold. Okay, and the final product is object. Okay, think of like car like manufacturing company. Okay, car like is a manufacturing company. So car is getting manufactured. So in that manufacturing company, it has the design details, template, blueprint, what properties, what functionality it should have, and the final output, final product is BMW, Audi, and Tesla. So these are what final products are objects. Final products are objects, and the blueprint template designs are class. So here it is written, okay, real instance, real object of a class is object. Real byproduct, real product is object. Okay, let's move. Why object-oriented programming? Why we are learning these things? Okay, why do developers prefer this object-oriented programming? Because it helps organize code, okay, into small and manageable pieces. Instead of writing in one file, we will divide our application into different classes. So instead of making one big class, we will divide into several classes, different classes. This will improve readability, okay, reduce duplication, we can reuse code, and maintenance will be much easier with the concept of class and object. Large applications containing thousands of classes become manageable. How? Because we are following object-oriented principles there. Okay, so let's understand what are the 4 pillars of object-oriented programming. So object-oriented programming, that is OOP, is built on 4 fundamental principles, which we call as 4 pillars of object-oriented programming. What they are? They are encapsulation, inheritance, polymorphism, and abstraction. So we will study each of these concepts in detail in separate upcoming videos. But for now, just to have an overview, basic understanding, okay, let's briefly understand what each one means, okay, each of one. So we'll start with encapsulation. Encapsulation means wrapping data and methods into a single unit. Okay. Okay, before moving into encapsulation, I will show you here a quick glance of class. Okay. So how do we define class? Class and the class name. Let's say car. This is the class name. Okay. And inside class will be having properties and behaviors. Okay. So this is class. Class will have the definition. In this example, car. What properties and what behaviors this car will have will be defined inside the class. And now, when we create an object, how do we create an object in Java means? Car is a class name, right? Car is the name of class. Class is a keyword, okay? After class, we write class name. So car is a class name. So how we will create an object means we'll write class name car, then variable, so small c. Okay, focus on this thing. This is what class name here. Okay, here we have defined car. Now this is what variable name, variable. Okay, car equals to new. I hope you remember in the previous videos we have discussed whenever we use new keyword, that means object is getting created in the heap memory. Okay, now we are creating an object new. Of which class we are creating object? Okay, object will created, but what blueprint, what properties and what behaviors that object will have. So for that we are mentioning the class name. Okay, so this line, new car, new class name, it can be anything, but for this example, car. So this line, this statement will create an object, in the heap memory. Okay, think of it like this, stack and heap. There car object will be created, car. This is what object, car object. And in the method area, car dot class file will be loaded. And what is the variable name? Car. It will be sitting in the stack memory. Okay, and car object will have some memory location that will be stored in the here memory location of car object. So this will point to the car object, and inside car object will be having one class pointer. This class pointer will be pointing to dot class file. Okay, so this is like internal memory representation. We have already discussed this thing in the previous video, but my intention to let you know that the structure of class is somewhat like this. It will have properties and behavior. Okay, this is class, and how do we create an object of this class? Using new keyword, new class name. So this will create an object in the heap memory. Okay, and the object we have created, so this object will contain, okay, this is the object, right? This object will contain properties and behaviors of what we define inside the class. So let's say we have created one car, BMW. So BMW will have the properties and behavior which is defined in the class car. Okay, so this is a like basic overview of class and object. Now let's move on to encapsulation. Yeah, encapsulation means wrapping data and methods together, bundling data and methods together into a single unit. You can say like together into a single unit. So what we are making? Data, methods together into a single unit. So these things, data and methods, we are binding, data and methods we are binding into single unit. Okay, that is what we call as encapsulation. So encapsulation means wrapping data and methods into a single unit, which is a class. So just now I showed you one example, right? Class will have what? Properties and behaviors. Class will have what? Class car, properties and behaviors. So class is having properties and behaviors. Properties means what? Data, right? Behavior means what? Methods. Okay, and what we have written here, data and methods together into a single unit. So data and methods are in a single unit, which is class. So this is concept we call as encapsulation. We are encapsulating two things into one entity. So two things are data and methods, and one entity is class. So it also helps protect data from unauthorized access, or you can say protecting data using access modifiers. I will tell you in the later videos what are access modifiers. Okay, public, private, protected. These things are access modifier. How do we use what and all? We'll discuss in detail. But for now, you understand like it protects data. So with the principle of encapsulation, we protect data. Okay. So for example, a bank account should not allow anyone to change the account balance directly. Instead, users interact through method like deposit and withdraw. This keeps the data secure and controlled. Okay. So let's say you have one class bank. Okay. This is another example, bank. And inside class bank, you have some properties. Okay, properties and behaviors. Behaviors or methods. So methods, I will say, let's say deposit. Okay, and withdraw. These are the methods. Now, no one else can call this method, use this behavior. Only particular user can use this method or behavior. So that's how it is protecting data. Okay. We'll understand better in examples. But for now, you understand like encapsulation means binding data and methods into a single entity called class. So we are binding properties and behavior into class. This concept is called encapsulation. Okay. Now let's understand inheritance. What is inheritance? Okay. Inheritance. Inheritance allows one class to inherit the properties and methods of another class. You think of like your family, okay? How you inherit the properties and how you inherit the relation from your father, and your father will inherit from your grandfather. So inheritance is there, like inheritance hierarchy. Grandfather, then father, then child. So this is what inheritance hierarchy. Your father is inheriting from grandfather, child is inheriting from father. So child will have some similarity of behaviors of father, right? Something will be similar of father, and father will have some similarity of behavior of grandfather. Okay, think it that way. So some similarity will be there, behavior. So what, grandfather will have some behavior, so that behavior will automatically come to father. Then father will also have some behavior, that behavior will automatically come to child. So same way here, vehicle, in these are what, all classes, vehicle class, car class, electric car, these are classes. Okay, and each class, just now we have seen each class, what do they have? Properties and behavior. Behavior we call it as method also, right? Method, functionality, whatever we call. So each class has these things, property and behavior, two things. So car is inheriting from vehicle class. That means this car class will have properties and behavior of vehicle class. Okay. So whatever property and behavior vehicle is having, that property and behavior will be inherited to the car class. Now, car will have some properties and behavior. Okay. Now, electric car will inherit properties and behaviors of this car class to the electric car. Okay. If you have this analogy in your mind, you will understand this inheritance concept very easily. Okay, so car will inherit the properties and behavior of vehicle. Electric car will inherit the properties and behavior of car. Not only car. See, child will inherit the behavior of father as well as grandfather. Something, okay. But here, electric car will have properties and behavior of car as well as the vehicle. Okay. So what it is written? One class acquires properties and methods of another class. Okay. So in this class, vehicle is the parent class. How do we define this? Is parent class. Okay. Vehicle is parent class, and these are like child classes. Okay, child classes. So car inherits from vehicle class. Car inherits from vehicle class, and electric car further inherits from car class. So this avoids rewriting the same code multiple times and promotes code reuse. That means reusability of code. So whatever properties and behaviors vehicle class is having automatically will come to car. It does not require to redefine those properties and behavior inside car class. That will automatically be present in the car. Similarly, electric car will automatically have the property and behaviors of car class. It does not need to redefine these properties and behavior inside the electric car. Okay, so that's how reusability with the concept of inheritance is achieved. Okay, this is just an overview. We will see in the later videos in the much detail with examples. So let's move to polymorphism. So polymorphism, okay, polymorphism. Okay, so it means many forms. Okay, poly means what? Poly means many. Morphism means forms. Many forms. Polymorphism. You can think like polymorphism means one interface with multiple implementation. Okay, multiple implementation. So think of it like there is one interface. Okay, interface is just a concept, okay, in which we'll be having only declaration. I will tell you interface. So interface will have only method declaration. Interface will have only method declaration. Okay, so the class, let's say xyz, the name of class, will implement interface, any interface name, let's say abc. Okay, so implement interface. Here interface name will be there. Okay, interface name. So in the class we need to define that method definition. So don't worry much about interface. I will take separate lecture for this one, but for now understand this way, like there is one interface and multiple implementation. Think of like method we know, right? So we'll be having different forms of method. There will be one method. Okay, one method name, you can say one method name, but different forms. One method, different forms, many forms, that is polymorphism. Okay, so suppose multiple shapes, for example, multiple shapes are there. Okay, circle, rectangle, triangle, and each shape draws it differently, right? The method name remains the same. Suppose this is the method name, draw. Okay, so in each class, think of it as class. Each class have properties and behavior. Behavior means method. Think of it like each class will have methods. Circle will have method, rectangle will have method, triangle will have method. Okay, these are classes. Each class will have properties and behavior. Behavior means method, properties and methods. So circle will have method, rectangle will have method, triangle will have method. And that method is draw. Method name is draw. Now, in class circle, draw method will be defined. Defined means we will write lines of code that what it will do. Okay. So inside draw method of circle class, we will be drawing circle. Inside the draw method of rectangle class, we will be drawing rectangle. Inside draw method of triangle class, we will be drawing triangle. Okay. So same method, but it is being used in 3 different classes and with 3 different implementations. Same method name, but different implementation. Draw method will have in circle, in rectangle, in triangle. But the definition will be different. Here it is drawing circle, here it is drawing rectangle, here it is drawing triangle. But the method name is same. That's what polymorphism. One method with many forms. One method with many definitions, different definitions. Okay. So this is just an overview. We will read in detail. Okay. Now let's move to abstraction. Abstraction is a concept. Think of it like only showing essential details. Only showing detail and essential details to end user. Think of it like you are using your mobile. Okay. You are using mobile. You are just clicking one button, touching one screen, touching one play button, and videos are getting played. Okay. But background, what is happening, how it is playing the video, there will be some process, right? In the background, internally something must be going on. So after that process, you are able to see the video. Okay, so in the background, some process is going on, which you are not aware of. You are just touching play button and video is getting played. So that background process is hidden from you. Okay. So the mobile company is showing only the essential details to you. For you, what is important? The play button. So you will touch the play button and video will play. That's it. Only this is required for you. What is happening in the background, how the coding and logic is happening. Okay, those things is not required for you. So only essential details is showing to you and the background process is hidden from you. That's what abstraction is. So hiding implementation and only showing essential details to end user. You are the end user. It is showing only essential details, the play button, play, subscribe button, like button. So these things in the video, they are showing only essential details to you and you are just clicking on that, touching on that, and things are getting automatically. But the background process, what is happening, that is being hidden. Implementation is hidden from you. This concept is called abstraction. Let me take another example, a car. Okay, you drive the car without knowing how the engine is working. Okay, how engine is working, how is fluid mechanism inside going on, how the engine is working with different strokes. Okay, so those things we are not aware of. We are just simply putting gears, applying gears, clutches, brakes, and car is running. So hiding implementation, only showing essential details. Only those details are showing which is required for us. Okay, this concept is called abstraction. So similarly in Java hides complex implementation details and exposes only what the user needs. Okay, so any website in Google Chrome, if you open, or Safari, any website you are opening, okay, any website you are opening, google.com, then it is loading the page. Okay, in Google, here is the search box, it is opening the page, but what is happening in the background, how the HTML tags, what are the HTML tags, what are the UI pages, whatever background process is hidden from you, only the front end, front page, this is been shown for you. So this is the example of abstraction. Okay, so far we have seen the all four pillars of the object oriented programming. Okay, that is inheritance, polymorphism, encapsulation, and abstraction. So using all these four principles, we can achieve many things. What? Code reusability, better security, easy maintenance, modular design, scalability, easy testing, faster development. Okay, moving forward, when we write the code, you will understand reusability will achieve by inheritance. Okay, you remember father grandfather concept. So we don't need to redefine the properties and behaviors. It will be automatically coming from parent class. That's how reusability. Better security with the concept of abstraction. Okay, maintenance, design, scalability. Scalability means if we want, suppose we created one application and we want to enhance it since the users are getting increased. So we'll be creating multiple instances. How those things will be done, scalability. So if we are following these principles, this will be achieved faster in development. Okay. So object-oriented programming offers many advantages. Okay. This is why OOP is widely used in enterprise applications. Okay. So where it is used, what are the fields? Java applications. Okay. Android applications. So whether you are building banking applications, e-commerce websites, hospital management systems, okay, enterprise software, and many more, desktop application, gaming development. Okay, so these all are usages of object-oriented programming. So learning object-oriented programming is very crucial, essential for becoming a Java developer. Okay, let's quickly summarize what we have learned so far. So we have seen like what is object-oriented programming, what is class, what is object, and we have seen the real-world example like for car, and we have seen the real life object like BMW, Audi, Tesla. So how the object and the class, what class do have properties and behaviors, those things, why it is important. We have seen the four pillars of OOP: abstraction, inheritance, polymorphism, and inheritance, abstraction. So four pillars of object-oriented programming, and also we have seen the benefits of object-oriented programming. So that's all for this video. I hope this tutorial helped you to understand object-oriented programming. Thanks for watching, and I will see you in the next video.